All right, let's take a look at number 2 on slide 11. So this thing looks pretty intimidating. So remember, we're not worried so much about the computational part. We have calculators. We want to fall back on what we know in terms of the patterns we've been seeing, things we're observing that can give us an advantage and help us figure out the correct solution. So let's go through this process. I'm going to go ahead and use the equation letters as well. So let's go ahead and take a look at the original equation. I have 10x minus 7 plus 3x plus 1 divided by 2x plus 6 equals 4. All right, so let's get to work. What would I do first? Be my writing tool. So notice I have some like terms here. Different types of like terms. This is going to be some variable like terms. How do I know that they're like? Because they have the same variables and they have the same coefficients. So let's take a look here. I got 10x. Then I have 3x. Coefficient, coefficient. Check, check. Base the same, check, check. Power the same, check. They're like terms. So I can go ahead and combine this. 10 and 3 gives me 13, and I bring the x there, all right? So let's go and take a look at what's in the triangles. And notice how I've circled not just the 3, but the sign in front of it. And it's really going to be crucial here. So these triangles here, right? So notice I got 7 negatives, and I got 1 positive. That's me with 6 negatives, all right? So 6 negatives. And I go down here, you can see the 6 negatives here. Well, let's just go to a number line toward the idea of 7 negatives and 6 positives, or 1 positive. So we'll say right there, -7, -6, -5. Oh boy, it's doing that thing again. Let me make it go down. Go down, go down. All right. There you go. -5, -4, -3, -2, excuse that, and a -1, and then 0. So let's say that I'm at -7. All right, so -1, -2, -3, -4, -5, -6, -7. And then I have 1 positive movement. Okay, going back towards 0, positive 1 movement back towards -6. So that's the thinking behind 7 negatives and 1 positive gives me 6 negatives. Just using the number line there. All right, so we're finally done with letter. What is that? We were combining like terms. So that is letter B. And we didn't do anything to the 4, so the 4 just comes straight down. So now, okay, making things a little smaller. We had 4 things up there. We're down to 2. Works out of 4 terms up here. Now we're down to 2 terms here. So I have 13x minus 6 divided by 2x plus 6 equals 4. All right, so this is where things can get kind of, freaked out on you. So I'm going to go ahead and erase this so we have some clear space. So notice here, we really haven't dealt with a situation where you see something as crazy as this down in the denominator. Okay, but I want you to see things this way. If I was to multiply 1 by some number, we'll call the number x. Okay, so I multiply that one here. And then I had x over this. No matter what that is, wouldn't that cancel you out? Cancel you out. Cash me out, sorry. But cancel you out. So the 1 there and leaving you with 1. So let's take this idea of anything, 1 over anything, the same anything though. So notice that x, whatever it is, going to be the same thing. It's not going to be anything different. Just 2, it's going to be 2 there, whatnot. All right. So let's extend that thinking out. So let's go over here. Let's say I put 2x plus 6 over, oh, come on, man. Hold on. Let me push this back. Go back. All right. And put that over 1. So what's the idea here? 2x plus 6 over 1 times, what do you think? What do you think is going to be? 1 over 2x plus 6. But Mr. Heath, that has that 13x everything over it. Notice what I can do here. I could go 13x minus 6, slap that under 1, and go and put the 2x plus 6 under 1. I said under 1, excuse me, over 1, and put that under 1. Okay, and notice what happens. This is still cool. It is what it is. And I can remove this and set that up. Okay, but see, that's weird. That's crazy. Watch. Let's say if I, just multiplied here, like so I combine this, put my little dot and everything, right? Well, what's 1 times that? Now that's going to be 13x minus 6. What's this going to be times 1? Itself. 2x plus 6. Sure looks a lot like right over here. So if this threw you off, at this, just go back, rewind, slow down, and see what's happening here, okay? So that's the reason why I can take that whole denominator there, slap a 1 underneath it, and be like, bow. Okay? And I do that. I just don't do it here. I'm just showing you. I do it where? Right here. So notice right here, the same stuff I've been doing up here. Watch it play out right there. Okay? Now, I don't have, I didn't separate the way I showed you over there. Why? Because I'm kind of lazy. I don't want to do all that work. But you can see over here, sort of, that's why this happens. So watch. Go here, cancel out. Well, remember that? That's going to be 1. 1 times 1 is 1. Okay. And then there's nothing there. Okay, you could say 1 because, and that's 1 times that. And that gives us sort of that original situation. And if we divide 1 into that, that's going to give us our 13x minus 6 situation. Go back, rewind this. I know it's a lot of deepness or whatever, but if you have an opportunity, go back and see so you don't really get intimidated by things like this because they have like 2 terms in the denominator. All right, so we're going to go ahead and do what we just did right there. So what letter was that one? That was D. Okay, so we found a multiple denominator, the denominator itself. All right, so wait, I didn't put a letter for combined like terms over there. So let me put my B, terrible B. So B, then D here. And could I go ahead and apply another letter? You know I could. That letter is going to be letter C. We're going to apply distributive property here. Okay? But Mr. Heath, what did you say? Didn't you just multiply this side by that side as well? It's true. But I can go ahead and apply distributive property with that 4 to here. Are there other ways to do this as well? Yeah, but I think this is the simplest way. So apply distributive property. All right. So 2 sets of 4, 8. 4 sets of 6. Oh, yeah, and you bring the variable with you, the x, and then 4 sets of 6, 24. All right, so let's go up here. First, we combine like terms, all right? B. And then once we combine like terms, we had 13x minus 6 over here, divided by 2x plus 6 equals 4. Brought down to 4, remember, because we didn't do anything to it. Things got a little tricky here. We had to do a letter D. We had to do a letter D, which was the find the least common multiple, which is kind of something unusual. We have 2 terms in the denominator, but we figured that out. There's a process over there, the thinking, and then we applied letter C, distributive property here. Whew. And last but not least, well, not last but not least, but that with all that said, we're at 13x minus 6 equals 8x plus 24. So you can see by down here, I decided that I want the variable to be on the left-hand side when it's all said and done, and I want the number, integer, constant, whatever you want to say, to be on the right-hand side when it's all said and done. So let's go to the mix, okay? All right, so if I want variable only on the side, I got to get rid of this number here. So how do I get to 0 with this? If I have 6 negatives, give them 6 positives. Boom. Arithmetic, 6 minus 6 is nothing. What do I do on one side equal sign? You already know. I do on the other. That was 6 positives. I'll bring that over there. Algebraically, 24 positives, 6 positives, 30 positives. Arithmetic, the sum of 24 and 6, 30. Okay, gonna bring down that 8x. Why? We didn't do nothing to it. All right, so we're getting closer. Now, what was that? That's a letter A. We're doing the inverse operation. This time just with constant, integers, numbers, how you want to see that, no variables. And we go down here. Oh, wait, we are going to do a little inverse operation involving variables right down here. Because remember, I want the variables where? On the left-hand side. I got my numbers set up pretty good, right? Because the numbers over there are 30, so the numbers are looking good. Got to get the variables straight. So we go over here, algebraically, on the number line, if I had 8 positives, I hit it with 8 negatives, I'm going to get to 0, okay? All right, so then let's go over here and slash that. What I do on one side, I do on the other. So the 8 negatives come over here. 13 positives, 8 negatives, 5 positives. All right, that was another letter A. All right, inverse operation. Now we can finally say last but not least. We get to FB, baby. We're just going to divide the coefficient by itself, or the variable by itself. What's the coefficient? 5. I call it the eyeball check. What you see is what you divide by. So do a little quick wind up on that one. And we got our Invisible Uno. And then we do a wind up over here. Wind it up. How many sets of 5 are in 60? There are 6. Okay, I believe my solution is true. I trust it is. Let me go ahead and verify her over here, okay? So wherever I have the value, wherever I have the letter x or the variable x, I place the value 6. So I had 10 times the value of x. 10 times 6 minus 7 plus 3 times the value of x, which was 6. And you can see right there, plus 1 should equal 4 when it's all said and done. So we go through the processes. Notice I use kind of the shapes here to help me out, so I don't have to I don't line them up or anything like that. And then when it's all said and done, hey, the number on the left-hand side of the equal sign is the same as the number on the right-hand side. What this means is that 6 is the correct solution to the equation here. You can't put any other number. There's only one solution to this equation. You couldn't put 6.001. It would not be the same on the left and the right. You couldn't put 5.9999. It would not be the same. All right, so that wraps it up. I hope that better explains. If you still have questions, please reach out to me. All right.